Hello everyone, welcome to our presentation. We are group number 3 and we'll be discussing urban runoff today. Our group members consist of Leah Charles, Monica Coe, and myself, Torin Valdez. Let's get started. So our learning objectives today include landscape scale factors, human and environmental impacts, and legal frameworks to manage urban runoff. But before we get started on that, we'll discuss some background. So urban runoff is usually the result of atmospheric deposition in the form of precipitation, falling on impervious surfaces that are often host to anthropogenic activities, whether that's transportation, recreation, or industry or commercial uses. And these drainage surfaces might include homes, buildings, roadways, sidewalks, and recreational areas. Either way, as that precipitation falls on these surfaces, it collects as surface runoff, which then makes it into these urban drainage systems, which is usually a network of pipes and sometimes missed connections. And sometimes these areas are mitigated by stormwater control measures, and other times they are not, depending on how proactive an area is in terms of installing these measures or retrofitting developed areas. So we'll get started on landscape scale factors. Some of these factors include the distance and size of the contributing area, as well as the dispersal of pollutant sources within that contributing area. Topography and vegetative cover within the basin also are two additional factors, followed by the geographical distribution of events, specifically precipitation events within these drainage areas. As we know, precipitation events don't necessarily impact the entire area at the same time. It could just be smaller areas or up to the entire basin, which of course will influence the surface runoff and what chemical constituents and other forms of pollution will be in that surface runoff. So smaller landscape scales have little potential in contributing to runoff in contrast to larger areas, specifically when we're talking about urbanization. And of course, the closer a pollutant source is to a receiving water, the higher the likelihood that any surface runoff from that area will be higher in concentration of that specific pollutant or pollutants, and which has a greater potential of disrupting water quality in that receiving water. And of course, topography and vegetation have major impacts on hydrology as well as water quality. In this graphic taken from a paper by Gia et al., we can see that this gradient between the beneficial hydrologic functions and maximum potential erosion. So as vegetation cover is more matured and more present, the maximum erosive potential of surface runoff is much lower. So as we remove vegetation, we are generally increasing the erosive potential. And the slope terrain has, of course, higher gravitational pull on surface runoff in comparison to flatter areas, which might allow for the pooling of water, and that it would then evaporate or percolate into the soil, or rather infiltrate into the soil to be used by vegetation or percolate down into the groundwater. So these precipitation events result in differing infiltration rates and runoff rates depending on the area that it falls in because of this. So in a wooded area or a meadow area, as we see on the far left of this graphic, you see that a greater percentage of that precipitation becomes infiltration. That water collects on the surface. Most of it doesn't really move anywhere. It just infiltrates into the soil to be used by vegetation or to percolate into groundwater, versus a very small amount that runs off the surface. On the very right side of this graphic, we can see the urban business district and residential areas, which by contrast have much greater percentages of surface runoff in comparison to infiltration rate. And that's because of the impervious surface. There's not as much natural open areas where that precipitation can collect and then infiltrate into the soil. It will fall on impervious surfaces and then run off as surface runoff. And then in the middle of the two, we see this row crop agriculture example, where even though the area might still be vegetated, it's certainly not as much as it would in a natural setting, which often leads to greater runoff than in a natural setting. And all of these things, of course, impact water quality by picking up chemical constituents and by picking up temperature, or by picking up increasing in temperature. And so then that question becomes, what collects on these on impervious surfaces, and just a brief overview, things such as litter, trash, human waste, pet waste, as well as chemicals and any oils from transportation or industrial or commercial uses, which then makes its way into storm drains and then the receiving waters. So on the note of the influence of urban runoff on stream temperature, oftentimes these impervious surfaces, specifically asphalt, are great at absorbing heat and storing that heat, which then is transferred to any surface runoff. And as it makes its way into a stream, that greatly impacts water quality in that stream, which temperature is a parameter of measuring water quality in streams. And according to NOAA, sensitive streams can be affected by as little as 5% impervious surface in the drainage area. As impervious surface in the drainage area increases to 20% or more, greater impairments are expected. And so a good example of this is in the Pacific Northwest. I live in Washington, and that's a large concern, is the impact of urbanization on stream temperature because of high water temperature and its impact on salmonids, as well as other aquatic life. And so here's some graphical examples of these things. We've all seen, I'm sure, surface runoff that has a oily sheen to it because it has picked up different drippings from automobiles. But we also think of litter, and it's not all just the physical presence of litter, but what it could be leaching. And a good example of that is cigarette butts. Cigarettes contain thousands of different chemicals, and so as those cigarette butts make their way into our waterways, they begin to leach those chemicals into that water, and which impacts, of course, any aquatic life and impacts recreational uses and human health. And then, of course, road salt as well, and we use it to maintain safe roadways in areas with harsh winters, but they also have environmental impacts. According to the Minnesota Pollution Control Agency, an average of 365,000 tons of salt is applied to the St. Paul, Minneapolis area each year. So just in that area alone, that's a huge amount of road salt. And about 78% of that is transported to groundwater or remains in local lakes, rivers, or wetlands. So, and it builds up on the soils, which could potentially prove to be a long-term pollutant for that water body, because only a teaspoon of salt is needed to pollute 5 gallons of water. So relatively small amount of salt. And so while these storm drains help us manage any flooding that might occur in urbanized areas because of precipitation, it also allows for greater areas of land to be, in precipitation falling on that, to be funneled to relatively small water bodies. And so we think about the effects of grading and developing an area and how that might change the drainage area for certain streams. And that could result in greater flooding and erosion, which will, of course, impact human health, which we'll discuss shortly. So here's some environmental impacts as a result of urban runoff. Temperature, water temperature, and dissolved oxygen in that waterway are, of course, linked to one another. And as that surface runoff increases in temperature as it moves towards the receiving waters, and those impacts, as well as chemical constituents, will of course have impacts on wildlife and plants. But also the increasing sediment load and any materials that make their way into the waterway could also result in flooding. And as mentioned in the de-icing salt example, this could also impact soil health around these water bodies. And so, in addition to that, there's these human impacts, things such as bacteria from pet waste and human waste make their way into water bodies and could really result in waterborne illnesses when the public use these waterways for recreational purposes. But as well, in addition to this, greater sediment loading and more materials being introduced into the waterways could also result in flooding, as well as property damage as a result of increased erosion in certain areas. And then this increased sedimentation results in the need for greater dredging or dredging more often in areas that use these waterways as a kind of a shipping route. And then as a result of this these pollutants, that increases the need for water treatment if that water is being used as a drinking water source, because that, of course, could have health impacts. It has impacts to the taste of the water as well as the aesthetics of water. And then, which also brings up another point, is algal blooms as a result of eutrophication in the waterways and increased nutrient loads, which is a large concern in many areas and is becoming seemingly more common. Not to mention litter on shorelines as well. So in the U.S., the legal framework that really helps us manage urban runoff was introduced under the Clean Water Act, and specifically the National Pollution Discharge Elimination System, NPDES, which regulates the point sources of pollution discharging to waters of the U.S., which are often called WOTUS. So the NPDES system regulates three major sources of stormwater discharge. That's from construction activities, industrial activities, and municipal separate storm sewer systems, which I'll refer to as MS4s. There's also considerations from transportation and oil and gas, but a lot of those are kind of looped in under these other sources. And most states and some tribes are granted authority to administer the Clean Water Act laws, which this is commonly referred to as sovereignty or as primacy, which we learned in the first couple weeks of this course. And as a result of this, it requires the individual states, to pass laws that are at least as stringent as the federal pollution laws under the Clean Water Act. And as a result of that, they are given the authority to administer these laws. And I will see you over in section 2 of this presentation. I only have a limited time for this recording program.